Nintendo Switch, we will not be sticking power to this, and I'll show you why. There are a multitude of bent pins in that port. If we stuck power to that, or if anybody has stuck power to that, it would be highly likely to cause some collateral damage. Let's hope that's not the case. This video is brought to you by PCB. More about their awesome services in a bit. We have the board out of the housing and we are preparing to remove our port. While I am setting up my equipment, let me throw up my expected temperatures for this job. These temperatures are brought to you by the Amazon Associate links in the description. If you head to my video description and click on one of these links and buy any of this equipment, or if you buy anything during that session, a small portion of that purchase will go to supporting the channel. It won't cost you an extra dime, and I greatly appreciate you. Immediately, I will show you what's going on because it will be hard to miss. Dun dun dun. Somebody did stick power to this port, and we'll be very lucky if that did not kill the CPU. Will this customer be one of the lucky ones? First, we're concentrating on the anchors. Get them wetted. They will wet very quickly with a low melt. And now we'll concentrate where the pins are on the other side of the board. Once they have wetted, it will drop. Let's go ahead and pull this Pi 3 because we know it has to be pulled. No point in waiting. And we've lost a pad. May or may not matter. Nice clean pull on the port. We just want to check and make sure we have no bridging on these pads, and we don't. If we did, we'd need to clear it before we test. We'll begin our testing around the M92T36. First thing we will test is that capacitor that is tied to Pi 3 USB in the back, which we know had a big old hole in it. That's actually encouraging. Let's continue our testing. Okay, this line is short, so that's not good. Indicates we have an M92T36 issue. Or worse. That one's short. Let's check this guy right here. This one is tied to the APU/CPU. On this side of the cap, we do not want to hear a short. Have we gotten lucky? Let's continue our testing. Check around our MOSFET area. Let's check our awesome invincible fuse. Still being invincible, even though most of the power circuit has been blown. We'll make note that we do have a diode array on this. They can be problematic when that type of current has gone through the system. Let's check our test pads. None of these test pads should have a pathway to ground. That one does. As you can see, it has a via. That one's indicating we have our bad N92. Make sure our coil is not shorted to ground, but we have continuity through it. And we do. Let's check our test pads. Over here by the BQ. Everything seems to be okay there. Continue testing the capacitors around the BQ 24193. And we seem to be okay there. Let's confirm that we do not have a short here. And we do not. Excellent. If we did, it would be sayonara for us. Let's check our filters. We want continuity going straight through. There is some manufacturer residue you have to get through sometimes. Somehow this filter survived, even with all that current going through and blowing the trays and the chip. Let's remove our M92T36, test again. See if we've cleared our shorts. No more short. No more short. Excellent. Catastrophe seems to have been avoided. What we're looking for here is that center pad to wet. There we go. And we want that center pad to grab the chip before we let go. There we go. Remove the air, put everything tacked down, then press down and re-wet. Easy peasy. I'm probably going to use a lug here. First, we need to do some grinding on our trays so we can have a place to solder that lug. I want a pretty decent little runway to do that with. And a little bit of flux. A 10-hour runway. That should be adequate. I'm going to put some solder mask down in the spot where we'll be putting the lug. I don't care if it gets anywhere else. It can be scraped off very easily. That's about where I want it. I'm about centering it up after. Right about where I want it. I think that'll work just fine. I want to get a partial cure on it right here with the laser, and then I'll use my big lamp once we've routed and soldered down the tail. And yes, I'm wearing UV glasses when I do this. STS telecom amount of flux. Let's very gently route our tail where we want it to be approximately, and solder it into place. Let's just check and make sure we're getting continuity through. We are. Excellent. We're going to solder mask the tail. I don't care how much of this we get everywhere up here, because it's not going to be in the way of anything. I've grabbed my big lamp. I'm just going to stick it on there and let it cure for a little bit. Did you know PCB has its own store? Of course, what jumped out to me was the electronics tools, and I wasn't disappointed. Tools ranging from the TS100 soldering iron to a mini hot plate, USB-C amp meter, and so much more. Click my affiliate link in the description and check it out today. And we've returned, and we should be well cured at this point. Excellent. Now we need to do some strategic scraping. Looking good. We're going to tin it up. There's a little ball of solder here, and that should be more than adequate. Let's test from the pad. Excellent. Our new pad is going to wet before anything else does, but that's fine. Again, we're looking for the center pad to wet. We'll not release the chip until we are certain that that center pad has grabbed it. Solder has grabbed it. Tack down. Press it down. Clean up. Looks really well aligned and flat. Looking good. Our makeshift pad looks real good. We won't know if we've been successful with anything, of course, until we get this port dealt with. Place a ball of solder on our tip, and then we'll just glide the ball over the pads. We're not really making contact with the iron itself. Very good. And we're just going to run the solder over the pads. Like so. Place our port. And press down. Move our heat. And we're going to hold the port down until we see evidence that these pads, visible pads, have dried. Let's have a look at our visible pins just to make sure they're solid. When you're worried about that hidden row, you can sometimes neglect some of these pins. This one's loose. We'll go over each one of these. Check them again. Excellent. I hope this video is being helpful to you in your repair journey. Just a reminder, if this is something beyond what you want to try yourself, I do offer these services. Just head over to micromage.repair, click free quote, fill out the form, and I'll get back to you personally. See if we're getting anything resembling normal behavior. First test we'll perform is with our USB-C to 3.5mm adapter hooked up to our PSU. PSU channel 1, what we want to see here is just a quick jump in amperage and back down on both sides. Sometimes it'll play nice with the PSU, sometimes it won't. Okay, that looks normal. See if it does it on both sides. It does. Excellent. Now looking at PSU channel 2, we have our modified iPhone Power Squid plugged into the Nintendo Switch. We've retrofitted it with Nintendo Switch battery connectors, and we're going to activate using our OEM charger. Quick in and out should do. What we want to see here is just a steady climb in amperage with no hanging. Okay, looks pretty good. Hopefully we're booted up. Let's see if we are docking. And we are docking. Blown Pi 3 USB, blown off pad, destroyed port, and blown M92 T36. Excellent. We're back up and running on its battery. We're at about 12%. Let's go ahead and throw our Joy-Cons on and make sure everything is copacetic in that department. Charging both. I'm going to go ahead and throw their gain card in, and it's recognizing it. Excellent. Make sure we're picking up our networks. We are. And make sure we have Bluetooth, and we do. Excellent. If you enjoyed this video, I think you'll enjoy this one right there, and I'll see you there.